Hello guys, I'm GT Lim here. Today I'm going to teach you all how to count things. So the key concept that we will be going through is multiplication concept, permutation concept, and combination concept. Okay, so let's first go through the multiplication concept. First, if there's two events A and B, where B occurs after A, okay, and A there's 5 ways of possibility that will be occurring, and B there's 3 ways of possibility. How many ways can these two events be occur? Okay, so the number of ways is 5 times with 3. Okay, so whenever you got two events that is independent and one occur up after another, and you want to find that the ways of occurring of them one after another, which is you just multiply the number of ways of them. So 5 times 3 is 15. Okay, and we are done. Let's do one example. Okay, this is a simple example. You got 3 places A, B, and C, and you got 3 ways to move from A to B, and there's 2 ways to move from B to C. And what is the number of ways to move from A to B to C? Okay, so there's 2 events here, which I call the first event A, second event B. Okay, and then the event A is A to B. How many ways? 3. Event B is from B to C, which is 2. So what is the total number of ways? 3 times 2, which is 6. Okay, looks easy, right? Alright, now that we know the multiplication concept, we need to know the permutation concept. So what is meant by permutation? Permutation is basically if you are given R empty boxes or empty position. Okay, I put this as R boxes, and I got N balls here. N different balls, okay, different balls. And I want to put these N balls into these boxes. How many ways to put these balls into these boxes? Okay, so first of all that we know the multiplication concept, right? So we can see each box as an independent event. So first we put balls into the first box and the second, third, until the R box. Okay, so when we put in the balls into the first box, how many ways are there that we can put? There's N ways, right? Since you have N different balls. Okay, for the second one, since you put 1 balls in the first box, there's only left N minus 1 balls to put in the second box. And then in the third box, there's N minus 2 ways until the R box. How many ways you left? It's N minus R plus 1. Am I right? Okay. So what is the total number of ways to put N balls into R boxes? You just times the thing, just as what we learned in the multiplication concept. Since all these are independent events and they are occurring one after another, so this is N times N minus 1 times with N minus 2 times until N minus R plus 1. So how can we express this? Now we need to introduce a concept called factorial, where N factorial is 1 times 2 times 3 times until N. So what is this term? Can we say that it is a N factorial? It is obviously that it is not N factorial, because N factorial is 1 times 2 times until N. But these terms has a consecutive terms. How can we express it in terms of factorial? Okay, so we got N factorial here. What is the missing term? Okay, maybe I write this in blue pen and you can see. This is N minus R to 1. right? So what can we say that 1 times 2 times 3 times until n minus r? It is obviously n minus r factorial. So here comes the formula of permutation, which is NPR. So we can say that this is NPR. Note that for NPR, the arrangement is important. Okay? Arrangement is important. Arrangement is a concept that differs permutation and combinations. For permutation, arrangement is important. Okay? So let's do an easy example here. How many arrangements can be made to put 3 books out of 5 books on the bookshelf? Okay? So first, we pick out the books, right? Then we put it on the bookshelf. So from here, we can see that the arrangement is important. And by using an NPR, 5P3, and using a formula, you can find the number of ways. Okay? Can anyone press the calculator for me? I'm waiting for your answer. The answer is 60. Okay? So if you want to use the old way, you can say that there's 3 positions on the bookshelf and you want to pick from 5 books. So for the first one, there's 5 ways to put on it. Second one, 4. Third one, 3. And then you times it up, you will get the same answer, which is 60. Interesting, right? Okay. Now we look into the combination concept. Combination concept, since it's NCR, right? The C here is stand by choose. So basically you choose R object from N object. Okay? It's a number of ways to choose R object from N object, where arrangement is not important. Not important. Okay? So how can we prove this formula? Just as what we said, we want to pick R item from N subject, right? So now you got N balls, and you want to pick it from you want to pick R balls from N balls. All those balls are different. Okay? So as usual, we got R position here, and note that the arrangement is not important. So as what we picked just now, we pick the things as what we picked just now, and then now you times it up. But note that, let's say there's N balls, right? The first ball can be here, can be here, can be here, can be here for each ways. So we need to divide it by R factorial. Okay? So you get what I mean? This is N times with N minus 1 times with N minus 2 times until 1 divided by R factorial, which is N factorial divided by this divided by this. Okay? This is a way to prove it. But it's okay. If you don't understand, just remember, for NCR, the arrangement is not important, and it's a way to choose R object from N object. Okay? Let's do one easy example. How many ways to take 3 books out of 5 books? Okay, so what is your R here? You want to pick R terms out of N terms. So which is 3 books out of 5 books. Your 3 is R, 5 is N. So 5C3, which is 5 factorial divided by 3 factorial times with 2 factorial. What you get? Someone, can you press the calculator for me? Okay, the answer is 10. Easy, right? So that's it for today. If you all would like to see more math and engineering mathematics video in the future, subscribe. See you all next time.